All right, welcome to another lesson, 6.2, logarithmic functions. You should say logarithmic out loud, or logarithmic functions, logarithm. It's important you know how to say it, okay? Logarithmic functions we'll get into. They're probably new to you, but we're going to start by just going over some basic exponents. So solve each of these equations using your knowledge. So 2 to the x equals 8. So what is x in this scenario? Well, what exponent on 2 gives us 8? You can mess around with your calculators if you want. Hit pause. But 2 to the third would be 8. So x is 3. Next one, 3 to the what is 243. Again, hit pause, mess around your calculator, see if you can figure it out. It's going to be x equals 5. 5 on 3, so 3 to the 5th is 243. And finally, 10 to the what is 10,000? That's 10 to the third is 10,000. You might be asking, like, why are we doing that? Well, that's because exponentials and logarithms are inverse functions. Okay, they go hand in hand with each other. In fact, we use logarithms to figure out the x algebraically in exponentials. Before we do that, just gonna get some practice with logarithmic form and exponential form. Okay, you can see the two, and notice it's color coded. So the base for each is blue. It's a blue B, a yellow A, and a green C. Okay. If you look at the right one, I find it's better to look at the exponentials first. Base B raised to the C power equals A. Okay. Well, in logarithmic form, that's a log with a base B of A equals C. And it's important that you can say that correctly. Log base B of A equals C. Log base B of A equals C. I would practice that out loud right now. Log base B of A equals C. Log base 2 of 8 equals 3, for example. Log base 3 of 243 equals 5. Okay? It's important to practice being able to say those. A few more terms. We have a common logarithm. Okay? Common logarithms are just logarithms with base 10. So you'll see them written like this. Log base 10 of x. Okay? So the base is just 10. Now, those are common logarithms, okay? And so you'll see it like this most often, log just of x. If there's no base written, we can assume the base is 10. Let me repeat, if there's no base written, we can assume that the base is 10. That's just a math assumption that everybody makes in the world. And then logarithmic function, I'm just going to write a random logarithmic function. Log base B, that's a B down there of x, okay? And it's just like any normal function. Okay, we have the log base B of x on the right side, and of course, f of x on the left side. All right, this next one, we're just gonna compare exponentials and logarithms a little bit. So to start, we've got 3 to the x. You've already done the exponentials lesson and homework, so you should be a pro now, or hopefully you're a pro now. If not, that's okay, but we'll keep rolling. So I'm going to plug in -2, -1, 0, 1, and 2 into my exponential. If I do that, I'll get out the following values. Okay, your calculator might say 0.111 and 0.333 there for -2 and -1, but in a fraction, that's just 1/9, 1/3. I find fractions better. Those exact. Okay, now let's write the inverse. So we just wrote our regular values. I actually need to scroll up again so you can see it. We just wrote the 3 to the x values. Now, let's write the inverse values. And if you remember from a long time ago, well, first semester, the x's and y's inverse just flip-flop. Okay, so the y of the original function becomes the x of the inverse and vice versa. Just flipping the x's and y's. I'm going to finish those. All right, and we get those values. Okay, and let's just scroll down and graph those values. I'm going to go ahead and graph the inverse in blue, okay, and I'll graph the regular in red. All right, so there's the points where blue is the inverse. Let's put a little f to the -1, and red is the regular. So, we need red. Okay, then just draw the curves real quick. There we go. I have a little wobble in my red curve, but that's okay. And you'll notice, hey, those are inverses of each other. Remember way back to when we were first graphing and creating inverses, okay, they just tend to be reflections over that line, that y equals x line. Okay, and they are. The red and blue reflect each other over that line. They're inverses. Okay, what's funny, though, is the blue graph is actually a logarithmic function, and it's the following logarithm. Log base 3 of x. So f inverse of x is log base 3 of x. I just wrote right there if you couldn't find it. Okay? The exponentials and logarithms are just inverses of each other. All right, we can fill out some domain and range things real quick. I'll be fast about this. Okay, so this is information you've already been filling out in the previous lesson. Domain, -infinity to infinity, range 0 to infinity, asymptotes y equals 0, x-intercepts none for the red graph, and y-intercept, in this case, 0, 1. The logarithm's a little different. I'm going to fill in the information for the logarithm together now. Well, the domain, okay, well, that stops at 0. We never actually get there, but it goes all the way to infinity. Okay, that's all the possible x's. The range in this case could go all the way negative, so up and down, right? Or all the way positive. You know, it looks like it levels out. Logarithms actually don't level out. They just keep going forever. Kind of like an exponential goes up forever. Asymptotes, in this case, we never cross the y-axis, which is x equals 0. We don't have any y-intercepts because of that. And our x-intercepts 1, 0. Look how closely related all that information is. Okay, a lot of times just flip-flops. Domain and range trade places. Asymptote changes from y to x. Okay, instead of no x-intercepts, there's no y-intercepts in the inverse. Okay, and then the intercept we do have flips x and y, which makes sense because they're inverses of each other. All right, with what you just saw in mind, so you might have to look back to their page of your notes. Let's flip these from their function to their inverse. So I'm going to use a weird notation here. Well, I guess I won't. They gave us y equals. I'm just going to call each of those f of x. And so the inverse I write is going to be f to the -1 x. Okay, we're used to that inverse notation, so I just want to keep it the same. So in this case, f of x equals 10 to the x becomes log base 10 of x. All right. Those are inverses of each other. F of x equals 5 to the x gives us f inverse of x equals log base 5 of x. Okay, those two things are inverses of each other. And then f of x equals log base 3 of x. We just have to go backwards now. So that becomes f inverse of x equals 3 to the x. All right, and that's one that was on the other page. For example, 2 here says fill out the missing boxes in the table. Most of this is just switching from exponential to logarithmic form. This is going to be really important because it's going to be very helpful for us when we're solving some things. It's going to be very helpful on your quizzes and tests. You'll definitely have problems like this. So let's practice. B to the x equals a. If that's exponential form, if you look back to the previous part of your notes, you'll remember that the b was the blue. Okay, so the base of the exponential becomes the base of our logarithm. The exponent always goes off out by itself, and then the a comes in there. All right? Really important that your base is at a different level than your a. Your b and your a should be at different levels. That isn't log ba, it's log base b, that base meaning below. Okay, it's like a subtext. All right, 3 to the 5th equals 243. Well, we can follow that same pattern. Log, and the base is the 3, of 243. Remember that 243 is on the same level as the log, equals x. The 3 is just lowered. Excuse me, not equals x, equals 5. I'll do one more together. This time we're given the log base 25 of 5 equals 0.5. So the base becomes the base of our exponent. Remember, the exponent's all on by itself. So in this case, to the 0.5 equals 5. All right, go ahead and try the next two on your own. Hit pause. The answer is going to pop up in about 2 seconds. All right. One thing you'll notice that sometimes I've been writing what's called the argument of the logarithm in parentheses. Okay, you'll notice that on this one right there. I find it a little bit easier. Sometimes my handwriting is sloppy, and as you know, and my numbers move up and down. So when I'm writing logarithms, for example, log base 6 of 1/6, especially when there's a fraction there, it can be kind of confusing, okay, if I don't really take care of that. So I'm just going to rewrite that a little bit. I just find it easier that if I put a parenthesis in there, it makes it very clear that what's inside the parentheses is going to be the argument of the logarithm, okay? That completely separates it from my base. It is helpful for sloppy handwriters like myself. All right, this last grid here is kind of the last examples for this lesson. It says evaluate each logarithm, and the hint is rewrite it as an exponential expression first. So logs are really hard to do in your head. Like, nobody can do that. But we can do just regular exponent problems in our head. So let's switch these logarithms to exponential form. Okay, in this case, the base is 7 raised to the, well, we don't have anything over here yet. Okay, so I'm just going to write an x there. Raised to something equals 1. 7 raised to something equals 1. Okay, well, anything raised to the 0 power is 1. So 7 raised to the 0 is 1. Okay, let's look at the next one. 5 raised to the something is 0.2. And that's tricky, okay? Because what is 0.2 as a fraction? That's 1/5. All right? This is a little bit sneaky putting a decimal in there. Well, 5 raised to the x is 1/5. Well, based on our exponent rules from 6.1, we know that negative exponents will flip a base to the other side of the fraction. So in this case, -1, 5 to the -1 would be 1/5. And that's something we can go over together. Now, that's a little confusing to you, but 5 raised to the -1 is 1/5. If you don't believe that or you're unsure, go check in your calculator. It's always good to check. And we'll do one more together before I give you the answer for the rest. 4 to some power equals 256. Okay, 4 to some power equals 256. Okay, I got to cheat and use my answers on this one. That's a hard one in my head. That's actually 4 to the 4th. 4 to the 4th is 256. And one thing I want you to notice here, if you actually plugged that in to your calculator, log base 4 of 256, it would equal 4. Log base 4 of 256 would equal 4. What would come out of your calculator is 4. You just punched it all out. Okay. If you punched out log base 5 of 0.2, you'd get -1. The calculator would spit out -1. All right. Go ahead and try the rest of these. Okay. I don't want you to punch those into your calculator. I want you to try to switch to exponential form and then figure out which power works for the rest of them. So go ahead, in about 3 seconds, you're going to see the answers for all of them so you can check. All right, go ahead and check your answers. Some of those are a little bit easier to do than others. Some of them you can do mental math. Some you might need a calculator just to check. Yeah, that's logarithmic functions, switching from logarithms to exponentials. The fact that they're inverse of each other, that's lesson 6.2. You're more than ready to tackle your assignment. And of course, please ask questions or save your questions for me. Getting those questions answered is